terms of our gas law calculations and our gas law theory, right? Now we've done already Boyle's law, Charles' law, Gay-Lussac's law. Okay, today we're going to look at the combined gas law, okay? Now the nice thing, the combined gas law is on the back of your reference table on table T. Now all you have to do is look at it and be able to manipulate it, right? But as we always say, guys, before you start any calculations, you have to know what the variables mean. Okay, it's very, very important. So the combined gas law is P1, V1, K over T1, okay, equals to P2, V2 over T2. All right, no problem. And as we said before, we'll say again, right? P, V, and T stand for pressure, volume, and temperature respectively, right? Now we have P, V's, and T's over here. Now we agreed the ones mean initial or starting conditions, right? Or all conditions. We also agreed that the twos mean final, ending, or new conditions, right? So very, very important that we know these. Because if you don't know these, we cannot label the variables in our problem, okay? Then, you know, we're just mixing and matching and it'll be crazy. Okay, now the thing, guys, before we start plugging numbers in, I always like to cross multiply the temperatures before I start any calculations. So, here's what we do, as before. This T1 is going to go over here, all right? And this T2 is going to go over here, right? So what we're going to get is P1, V1, okay, T2 equals to P2, V2, T1, okay? Now we're going to use the combined gas law this way, okay? P1, V1, T2 equals to P2, V2, T1. And we're going to isolate the variable that we're looking for, solve it, no problem. Okay, so let's do the example. Okay, so let's see, bam, all right, I think that's good. All right, so let's read that. A balloon, right, has a volume of 120 liters. You should read it slowly, carefully. You stop for a second. Now, guys, what's also very important, you have to know what the units mean, okay? If you don't know what the units mean, don't suffer in silence. Research them. You gotta know milliliters, liters, centimeters cubed, decimeters cubed. That refers to volume, people, okay? You have to know this. Very, very important, all right? So since we're starting out with this volume, that's gonna be our V1, okay? You can label it on the side someplace, or you can label it on the just under the actual variable in the problem, no problem. But make sure you label your items, right? Okay, I'm gonna read on. When the temperature, right, is 50 degrees C, okay? So that's our starting temperature. That's gonna be our T1, okay? Now remember, when we're using temperature in gas law problems, we don't use it in degrees C. We're going to convert that to Kelvin, yes? And if you don't know how to convert degrees C to Kelvin, no problem. The formula is on the back of your reference table. It was whatever the degree C you have, you're going to add 273 to it, okay? No problem. All right, I'm going to read on. And a pressure of 90 kPa, okay? So we go to pressure, that's our pressure 1. Now remember, guys, the thing about combined gas law, right? There's no constant variables, right? So there's nothing disappearing. There's no pressure disappearing or volume disappearing or temperature disappearing. We're using all the variables, okay? So it's very important that we label everything correctly, okay? And read the question properly and slowly and you know, make sure we're okay, all right? So that's our P1, pressure. That's our T1 for temperature. Now guys, these are exaggerated numbers. 90 kPa is like a really, really crazy pressure because our normal atmospheric pressure is 1 1.0. It's fine, no, never mind. I was thinking about 1 atmosphere, my bad. So 90 kPa is fine. Okay, it's a little less than 1 atmosphere. All right. Okay, so moving on. What will be the pressure at 10 degrees and 32 liters? Okay, so now the temperature changed, right? To what? To 10 degrees. All right? So this is going to be our T2. It's our new temperature. All right? Our final temperature. And this right here is going to be our new volume, our final volume, right? So that's going to be our V2, okay? So what are we looking for? We are looking for, guys, our new pressure, which is P2. We don't know what P2 is. So before we jump into any kind of calculations, let's convert our temperatures. Let's convert them to Kelvin, all right? No problem. So, if this is 10 degrees C, right? Okay, this is our T2. We need to add 273 to that to convert it to Kelvin. So our T2 is going to be equal to 283 Kelvin. All right, bam. Alrighty, no problem. And here, we'll do the same thing. We got 50 degrees, right? And we're gonna add 273 to it, okay? Alrighty, so 50 plus 273, that's 323, if I'm not mistaken. Okay, 5 plus 7 is 12, carry the 1, yes, okay? So 323 Kelvin, bam, alright? So now we're good to go, okay? We labeled all our variables correctly. We understand what we're looking for. We're looking for P2. We're going to solve this problem now, okay? All right. So we agreed from over here, right, that we're going to use P1, V1, T2 equals to P2, V2, T1, okay? Because remember, we cross-multiply the temperatures, right? Now, what do? We ask ourselves, what are we looking for? We are looking for P2. And remember, guys, from before, right? Whatever you're looking for, whatever you want to isolate, put an imaginary box around it, okay? And look to see what's left on the side of it, okay? Now, on the sides of it, we have V2 and T1, okay? So what do we do next? We simply divide both sides by these guys on the outside right here, okay? Anything on the outside of the guy you want to isolate, divide both sides by that. So, these guys are on the outside. We're going to divide both sides by V2, T1. V2, T1. We're not panicking. We're taking our time. We want to isolate P2 by itself, right? Now we realize, right, that V2s are going to cancel. Bam, they're gone, okay? We also realize the T1s will cancel. Bam, they're gone, okay? So now we successfully isolated the P2, all right? We're good to go. Now, the only thing that could mess us up is if we don't put the correct variables in carefully, okay, and do this problem, all right? So here we go, okay. So now we have P1, okay, pressure 1, which is 90 kPa, all right? So 90, I'm gonna put a little 90 there, kPa. Always try and use units, people, all right? Okay, our V1 is over here, it's 120 liters. So we're gonna put a little 120 L right there, bam. Now be careful, our brains are used to ones now, right? P1, V1. Sometimes you make a mistake and put T1 here, right? But this is T2. So that's why it's important to isolate your variables, label them properly, plug your numbers in. So T2 is going here, guys, all right? So what's T2? T2 is 283. So we're gonna put, okay, 283 Kelvin there, bam, okay? Alrighty, so we got our 90 kPa, 120 liters, and 283 kPa, our T2. Alrighty, V2, second volume, is 32 liters, right? Okay, so we're gonna put that there, bam, okay, and our T1, okay, our initial temperature, T1, is 323, bam, okay, 323. All right, let me go grab my calculator, and I'll be back. Okay. Alrighty, so what are we doing? We have 90, all right? Times 120 times 283. Okay, that equals to that. So I'm going to divide by 32. Okay. Okay, that equals to that. I'm going to divide again by 323. Okay, and we get 295.7. Okay, 295.7 as our pressure 2. All right, 295.7. Okay, and the units will be kPa. All right, because Kelvin here and Kelvin here cancel, liters here and liters here cancel, and you're left with kPa, and you're done. This problem is successfully solved. All right, you know what? Let's do another one. Let's do another problem. To wrap it up to make sure we're okay with this. Alrighty? So you guys can see. Alright, okay. So if 10 liters of oxygen gas at STP is heated to 550 degrees C, what will be the new volume of gas if the pressure is increased to 2.5 atmospheres? Okay, so here's the deal, guys. As we stress always, right, anytime you're doing a calculation problem and they mention STP, there's hidden numbers there, right? And you don't have to panic. Where do you look? You look on table A of your reference table. It has standard temperature and pressures there, right? So that's what STP stands for, standard temperature and pressure, right? Okay, and be careful of what units are they using in the problem. So we have here 10 liters, right? So 10 liters is going to be what variable? Okay, starting what? Starting volume. So that's going to be our V1. We'll leave that guy V1. Bam. Okay. Now STP, okay, standard temperature is either going to be 0 degrees C or 273 K, right? And from experience, we always use Kelvin in our calculations. Yes. So we're going to use 273 Kelvin, okay, as our T1. Okay. So T1 is 273 Kelvin, okay? Now, what's our P1? Also, it's hidden here, okay? Now, when you look at the problem, right, notice they're using the unit of atmospheres, yes? Okay, so we're gonna take advantage of that. The pressure one, what we're gonna use is 1 atmosphere, 1.0 ATM, okay? And that 1.0 ATM is gonna be our P1. Okay, so once again, guys, anytime you're doing a calculation problem and they have STP in it, don't panic. Look on table A. The values are there for you. Okay, no problem. And if they're using mmHg or torr, just remember it's 760 is standard pressure for torr or mmHg. No problem. Okay, at 550, it's heated to 550. So we started at 273 K. And now we heated it to this guy right here, 550 degrees C. Now, once again, we're not going to use degrees C, yes? So this is our T2. We're going to convert that to Kelvin in a second. All right. So what will be the new volume? So that's our what? That's our V2. We're trying to find that. That's our X. That's our question mark, right? Of the gas if the pressure is increased to 2.5 atmospheres. So that's our new pressure. Bam. P2, okay? Alrighty, so, here's my calculator. Right here, okay? As I always say, I used to be able to do it in my head really quick, but age has betrayed me, no problem. So no shame, 273 plus 550, okay, gives us what? 823, alrighty? Okay, so 823 Kelvin is our T2, okay? Alrighty. So here's the deal, guys. Let's set it up. So once again, what do we have? We have P1, V1, T2 equals to P2, V2, T1. How do we get this? Back in the reference table, combined gas law, we cross multiply the temperatures, right? Ask yourself, what are we looking for? We are looking for V2. We don't know what V2 is. We want to isolate this guy right here, so put an imaginary box around it. Bam. Okay? We ask yourself another question. What's outside of V2? It just so happens P2 and T1 are outside of the V2. Bam. Bam. Okay? So, what goes in the bottom right here, P2, T1. Exactly these guys in the bottom, and what we do to one side, we do to the other side, right? P2, T1, we're almost there. What happens to the pressures? The pressures get canceled. Bam, bam, and bam, and bam. The temperatures also disappear. All right, so we successfully isolated V2, our question mark. We don't know what that guy is. So how do we solve for V2? Carefully look at the problem, carefully place the values in, people. All right, so let's do that. Pressure 1, okay, hidden here, 1 atmosphere, okay? So we're gonna go here, we're gonna go 1.0 ATM, little small 1.0 ATM right there, bam. Our V1, our initial volume, just so happens to be 10 liters, okay? Bam, 10 liters. And our T2, be careful now, we went from 1 to 1 to 2. T2, okay, our second temperature, right? Our final temperature is 823 K, all right? Bam. Okay, so 823 Kelvin, all righty? Okay, no problem. All right, our P2, our pressure 2, right here, is 2.5 atmospheres, ATMs, bam. Okay, our T1, our initial temperature is 273 K, 273 Kelvin. All right, let's check our units, how they cancel. So we have ATMs here, they cancel, right? We have Kelvin here, we have Kelvin there, they cancel. What are we left with? We're left with liters. What are we looking for? We're looking for volume, okay? So we're happy, all right? Now, all we gotta do now is simply what? Simply calculate it. We're good to go, and you know, we're done, we're happy. Alrighty, so let's do that. So we have 1 times 10, so that's 10. Okay, times 823. So that's 8,230, right? Just no problem. Okay, bam. Divided by 2.5. 0.5 equals to that. I'm going to divide that by 273. 273 equals to that. Okay, so I got 12.058, so we'll round up to 12.1 approximately. Okay, and we're done. So, final answer is 12.1 liters. That's our V2, and you're done. All right, guys, nice and simple. You set it up properly. You label your variables. You don't rush to calculate. Take an extra 2 minutes and guarantee that you get a problem right. All right, people, as always, hard work plus sacrifice equals success. Study hard, do well. All right, no problem.